We're at gotomath.com. Check it out. Click on the calculus. Let's go down to numerical integration. And we're going to be looking back at Simpson's rule. To get a little bit further explanation on Simpson's rule, you might want to check these problems out. We're just going to kind of run through this. We're going from 0 to pi halves cosine dx. Let's see, use Simpson's rule for approximating a definite integral. Remember, in Simpson's rule, n must be an even number. So if you're gonna go out, let's say to 8, or the next one over, you want to do 6 or 8 or 12 or whatever. Round to 4 decimal places if needed. All right, so let's go ahead and write this down. 0 to pi halves of cosine x dx. 0 to pi halves. Is that what that said? Cosine x dx. So we're using a method here that for approximating this guy called Simpson's rule. And first thing we're going to do, let's get delta x. So delta x, remember, is b minus a over n. N's the number of subintervals. And let me just go ahead and write this up here. F of x is equal to cosine x. We're on the interval between 0, pi halves, and we're saying n is equal to 4. All right. Okay, I just wanted to make sure I wrote something down right. Okay, so delta x is going to be pi halves minus 0 over 4. So this becomes pi eighths. Pi eighths. And let's just go ahead and do this. So we start with 0. Okay, always a here, plus, and then delta x is pi eighths times 0, so that just ends up being 0, right? X of 1 is 0 plus pi eighths times 1, so that becomes pi eighths. And then x of 2 is 0 plus pi eighths times 2, so we can reduce that down to pi fourths. X of 3 is 0 plus pi eighths times 3 is 3 pi eighths. If you're not familiar with Simpson's rule, you might want to check out section 2 there, or button 2, whatever you want to call it. Check that out. 0 plus pi eighths times 4, so that's going to reduce down to pi halves. Okay. Now remember, I'm just going to write this down over here, b minus a over 3n. Remember how this goes. F of x naught plus 4 times f of x1. So the idea was, well, you got to remember these coefficients, the patterns here of the coefficients. x2 plus 4 times f of x3, wrong. This should be a 1 right here. Or no, this should be a 4. Yeah, I had that right. And then I've got to remember it. And then the last one, f of x4, has a coefficient of 1. So the one before the last one, you need to make sure it's a 4, and then the last one has a coefficient of 1. Okay. All right, so we have b minus a over 3n. Now what I'm going to do is let me just go ahead and let's do this. F of x naught is equal to, all right. So x naught is 0, and our function, which you can barely see up here, was cosine x. So we have cosine of 0, and you know what, we'll just leave it right there. Okay. And then the next one, we have 4 times f of x1, so we have 4 times cosine, and x of 1 is pi eighths, and then 2 times f of x2, So this would be 2 times cosine. X2 is pi fourths. Do we remember what that is? And then we have x of 3, so we're going to end up with a 4. F of x3 is equal to 4 times cosine 3 pi eighths. 3 pi eighths. And then the last one, f of x4, is equal to cosine of pi halves. Remember what that is. That's an easy one to know. Alright, so now we're going to come over here. So we have b minus a over 3n. So b was pi halves. I actually forgot that. So we have pi halves minus 0 over 3 times 4. And now we're just going to sum all these guys up. So we have cosine of 0. Does anybody know what that is? Hopefully you do. Cosine of pi eighths plus 2 times cosine of pi fourths plus 4 times cosine of 3 pi eighths, and then I think I can actually squeeze this last one in. Cosine of pi halves. Alright, close that off. Alright, so remember we went from 0 to pi halves of cosine x dx, and this is going to be approximately, so I'm going to pause at the pause and get that. Alright, I ended up getting 1.00134, and I think there was some other stuff out there. So we should get 1.0013 as our answer. I think we're rounding to 4 decimal places. Let me go back and take a look at that. 4 decimal places. 1 point. Oh, I think there was another 0 in here. Sorry. 1.000134. Yeah. So 4 decimal places. 1.0001. I believe. 1.0001. Okay. So I wrote some script that actually comes up with this, and at some point in time there will be a link on here on the get the algorithm, how to write the algorithm actually, because theoretically in the real world that's probably what you want to do. You want to crank this stuff out by hand, right? But we need to learn how to crank it out by hand so we can actually write a program that will do this for us. So that's extremely important. All right. So come on by, go to math.com. See you later.